Evening. Welcome to your mathematics class. This would be the beginning of a long journey of mathematics as we tackle exams for next year. Now, we would be using this platform for our classes so that you can join without having to worry about your network or the speed of your browsers. With this platform, it is certain that you'll be able to join without having to stress so much on whether your network is fast or not. This will allow you join better. Also, if you have any questions, you can always put them in the comments. I would read the comments from time to time. I have myself also connected to this stream. So if you have questions, I will definitely read them as well. So I would also put up some questions during the course of the class that I would like you to provide answers to in the comments as well. So make sure to keep this class interactive as possible. You have paid for this, so it's also very, very important that you are ready to learn. So let's start without wasting too much time. This is mathematics. We have a long list of topics to cover, and we will take them from section to section. Now, we'll be breaking mathematics down into 4 or 5 major sections, and we will pick each section one by one. Let me list out the sections we will do for mathematics. So this would be the list of sections that we have to cover from now till March. The very first section would be the calculus section. The second one would be logic. The third one is algebra. The fourth one is statistics and probability. And then the fifth one is geometry. So these 5 sections are sections that we will cover in mathematics. Now, there are a lot of topics that are in each section. So we will pick a section first, and then once we have treated all the topics in that section, we will move to another section. Hopefully by March, when it's time for exams to start, the very first exam that will be coming across next year, 2025, is the Jamb and WAEC exam. So hopefully before then, we would have completed all these sections as well as taking as many questions as possible. Also, once I'm done with the class, I would also pass across a list of questions or assignment questions that you have to give answers to. I would send that across to you as well through your facilitators, and you would have to give responses to them. If you have any questions, you can also send it to your facilitators on the group, and they would give responses, or they will send it to me and I'll give responses to it. So that would be the modality of the classes that we would be doing. Now, let's start. Today we will be delving into the calculus section. So you can probably write this in your notes so you know this is what we are going to be covering um, for the course of this class. So let me give you a few seconds to get your notes. Now, the materials you will need: your notes, your pen, your calculators, and any other writing material you need. So take 30 to 40 seconds to write what you need.
Short and
Just use it. So
I want to put it landscape. Landscape.
you can turn it from the top. All right. So I'm sure we are all set. So let's begin. First off, we'll start with calculus today. So under calculus, we will have two major branches, which will be our focus. We'll have differentiation and we will have integration. Now, these are branches under which there is a lot of topics that we have inside it. From differentiation, we have product rule, we have function of functions, we have all of that put together. I will pick in each branch all the topics inside. Same thing for integration, we have different topics which are like the methods in which you can use for integration by parts, partial fractions, and all of that. Now, today, in today's class, we'll give a brief introduction to what calculus is, and then we will begin our journey into differentiations. So, over the next two classes or three classes, we will be able to completely look at the calculus section. That is how we'll be progressing. So once we are done with the calculus section, we will now move on to other sections. Now, it is also very, very important to note that even though we call this the calculus section and this is where we are going to be doing differentiation and integration, there are also going to be some interrelationship between this calculus section and some other sections that we would look at later. For instance, when you get to under algebra and we start talking about other concepts like the quadratic equations, the polynomials under those concepts, and we start looking at those concepts in detail, there might be cases where, based on those polynomials, we might want to differentiate them or we might want to integrate them. In that case, the knowledge you have gotten from here will serve as a good advantage for us. So it's also very, very important to keep that in mind. But the most important thing is to know that, number one, all the knowledge you get from each section is linked. And number two, it's very, very important that you practice on it. So that's where our focus will be today. So let's start. First off, when we say calculus, we are simply talking about operations on variables in mathematics. Now, this calculus, or you can just say calculations, simply talk about various ways or instruments in which those variables can be converted or can be simplified or can be solved. Those are like very, very important keywords. Now, what are the kinds of variables you can have? You can have what we call algebraic variables. So you see interrelationship with the algebra section, but we are just going to be using the name here. And what are those algebraic variables? They are the variables that are the most common ones you find. All those your x squared, x cubed, xy, etc. All of these are termed algebraic variables. The general form of the algebraic variable is ax raised to power n, which is the variable has a coefficient and then that coefficient has a power, or that variable has a power. So this is the variable here, this is the coefficient, and then this is the power. Later on, when we go into the algebra section, we will talk about indices and logarithms, and from here indices will make this concept of powers much more clear to you. Now, this is for the algebraic variable. Another kind of variable you would have under calculus is the trigonometric variable. Now, these ones, you would find them in the geometry section. Examples are the common ones you know: sine theta, cos theta, tan theta, and a bunch of other ones. They are called trigonometric variables. Now, I write it as sine theta, so it's very, very familiar to you. But don't forget that theta is just an angle, which means I can represent theta by anything. it will still take the position of the angle. So in calculus, you'll be seeing it, you won't be seeing it as sine theta most times, you'll be seeing it as sine x cos x tan x, because most times the variable, the independent variable will be x. And the general form changes for each trigonometric function, right? For each trigonometric function. So I'll write one of the trigonometric functions, the general form of it, and then we'll use that to just assume for the rest. So the general form for the sine function, for instance, is given as a sine bx. Now, what a sine bx means is that a is the coefficient of the trig function, and b is the coefficient of the angular variable. So in this case, bx is the total angle, and then a is the coefficient. So for instance, if you have sine 90 degrees, you say 90 is the angle, yeah? But then you know that I can write sine 90 as sine 2 times 45, which is still sine 90. But in this case, I have written 90 in terms of a coefficient and then a smaller angle. So 45 here takes the position of x. And this is not the only way I can write sine 90. I can also write it as sine 3 times 30, and so on and so forth. So that's what bx is showing here, that the angle can be represented in terms of a coefficient and a variable. This is going to be very, very important in calculus. There are also other different kinds of variables. Another good kind of variable is the exponential variable. I hope you are taking notes of all of this. Now, for the exponential variables, they are also very, very unique in how they are formed. And the most unique thing about them is that they always contain the letter e in their writings. So if you have e raised by x, or you have e raised by 2x squared, or stuff like this, then it's the exponential function. Because e is present, this e is present as a variable most times in the base, so it is called an exponential variable. Now the general form is a e raised to power bx, or let's just say a e raised to power b. So that we call it a raised to power b, but if you want to put x, that's fine. Where a is the coefficient of the exponent, and then bx is the power of x, is the power on the exponent. Now this is very, very interesting. The reason why it's so interesting is the fact that b here can take the value of other kinds of variables that we have already seen and some that we have not seen yet. What am I saying? I'm saying because of the way the exponential function is formed, I could have forms like e raised to power sine x, and it's an exponential function. But in this case, the power is a trig function. I could have e raised to power 2x squared or e raised to power x like this. In this case, the power is an algebraic variable. I can also have different other kinds of functions that will serve as the power on the exponential variable. Different kinds. Any other variable you have can serve as the power of this exponential variable. And what that immediately tells you is that there can be an interrelationship between all of the variables when you are writing them. So it's not as if algebraic variables will appear on its own, or trig variables will appear on its own. They can be combined. For instance, the trig variables can also be combined with the algebraic variables, which is what we have here. X is obviously an algebraic variable. I could also have it as sine 2x squared, where 2x squared is the power, things like that. So you can combine them. And how you are able to solve based on all of this is one of the key things that calculus wants to test you on, which is what we are having, or we have to learn. And then before we go on, before we get into those talks, let's look at other types of variables. Another beautiful type that is also very, very important is the logarithmic variables. Now, the logarithmic variables means that you are using the log function. Now, When we look at indices and logarithms, when we get to the algebra section, you would find out that uh, the log is not just the normal log. When I say normal log, that means I'm saying log to base 10. There are different other kinds of logs, which are very, very important. Another very, very important popular kind of log that we have in mathematics is the log to base e. And the log to base e is translated as the ln. So you would have seen it on your calculator, and ln, or sometimes you see the in, which is the ln function, which is a log to base e. So when the base is e, and don't forget what the e is just this letter e that is also attached to the exponential function. And the e has a value. The e is approximately 2.718 in values. So when the log is to base e, then we are talking about the natural logarithm. So this is called the natural log, where this one is usually called the common log. So those are very, very important things. And we can define the logarithmic variable based on these two. But the most important one is to define it based on the logarithmic variable. So we could have ln x, could have ln 2x, you could have ln sine x, and so on and so forth. And when I say ln 2x, ln x, ln simply means that I'm saying log to base e of x. So x is the number, a is the base. This is a simple syntax for logarithm that we'll still get to discuss in detail later on for algebra. So the reason why this is very, very important is that you get to see that simple topics like indices and logarithm that you will normally want to overlook, that's so simple. Why do I have to do indices and logarithm? However, it is very, very important. It is important because they contain frameworks that are very, very useful in much more advanced topics like calculus. So that is something you have to keep your mind in. So by the time we're doing this logarithms in algebra class, make sure to attend. And if you are not yet sure you want to be attending our classes, this is a very good eye opener to know that this is a class for you to attend. All right, so now let's keep on. The general form for the logarithmic variable is to have it as a ln f of x. So let's just say a ln f of x, because f of x in this case can be any kind of function, just like all of this. I could write it as a e raised to power f of x, but in fact, instead of using the function, let me just use the simpler one, bx, like we have been using so far. So in this case, a is the coefficient of the ln function, and then bx is the number attached to the logarithm, position of this x, 2x, sine x, and so on and so forth. So this is the logarithmic function. And you see one major thing is the fact that they all have their like clear way in which we write them, as well as how we express them. Because of this clear way in which we write them, it will also mean that when it's time for us to solve it, there will also be clear ways in which we will solve it. So today, we would start first and foremost with our focus on differentiation. So we'll see how far we go into differentiation, and then we'll continue next week with whatever we have left. So we are doing these classes back to back till March. So make sure to attend everything. Um, and of course, I'm sure you have been told that even if there are portions of the class that is not so clear to you, you can always request for the recording that will be made available to you. And then you can also send us a message real time. I'm monitoring the phone to see if there's any message for me, and I would give a response to that. So let's start. Differentiation. So the very first thing that should come to your mind when you see differentiation is the concept of change. We are simply changing a particular variable with respect to the other variable. Now, this change is something that has a preset pattern, in the sense that the change that is going to happen to the first variable is very, very similar to the change that happens to the second variable. So it's not as if there's a detachment. Now, what is the relationship between the first and second variable that we have been talking about? Let's look at it. For instance, if I write the general form y is equal to f of x, right? From your basic knowledge of mathematics, this is assumed to be a class that prepares you for final exams, O level, Jamb, GCE, WAEC, NECO. So it means that you should have some sort of foundation in maths. Even if you don't, we are here to build that foundation. But let's take this one and piece it out. If I have y equal to f of x, I'm simply saying I'm assigning y as the value of the function. Now, this means something very, very important as well. Another thing that is very, very important that this means is the fact that x here is the independent variable. Now, when I say independent variable, what does that mean? Independent variable means that, from the word independent, it can do whatever it likes, right? Its decisions are the only thing that matters. Are we together? It's the independent variable, which means that the function is needing that x in order to exist, right? X is the independent guy, is the guy that holds all the power. Y, which is what the function is called the dependent variable. From the word dependent, it means that for y to exist, x must exist, which means whatever x decides to do determines what y becomes. So while x is free to do whatever it likes, y's decisions or actions is dependent on whatever x does. So a good example is, let's take a family setting, for instance. In that family setting, the entire family depends on the breadwinner of the house to bring in food. Whoever the breadwinner is, it might be the dad, it might be the mom, it might be the eldest son, it might be the eldest daughter, whatever case it is. But for the family to eat, they need the breadwinner to bring in food. So the breadwinner of that family is the independent variable. And every other member of the family is the dependent variable, because they depend on whatever food the breadwinner brings. Does that make sense? It's the same thing that happens here. Y depends on whatever choice of value that x brings. And x is the independent variable, which means that in that family, if the breadwinner decides that, in fact, today I don't want to bring any food home, then it means the entire house is going hungry. Because if breadwinner could have decided, I just want to eat my own food at work, and I don't care if any other person has not eaten, that's not my problem. In that case, the breadwinner will eat, but the entire family will go hungry. So the choices the independent variable makes determines whatever happens to the dependent variable. So that's very, very important. It also means that if there's going to be a change to the dependent variable, that is, if there's going to be a change to y, it is going to be because a change happened to x. Does that make sense? If y is going to change, it is because x is changing. And that is the principle for differentiation. Differentiation tells you that if there is going to be a change in y, it is going to be with respect to a change in x. And that's what you call the y dx. That is so familiar. You say the y dx, the y dx, the y dx. That's just differentiation. If there's going to be a change in y, there has to be a change to x. That's why we read it as the differentiation of y with respect to x, or differentiate y with respect to x. Now, this is just one way of writing the differentiation in terms of y and x. You can also write the differentiation in terms of the function. And another notation for it is to see it as f prime of x, right? Now, I won't necessarily call it prime, it's just to say the first differential of x. Another way in which it can also be written is